So good afternoon, everyone. We're bringing our panelists up online right now, and we'll get started in just a few moments. All right, it looks like we've got our panelists. So we'll go ahead and get started. Good afternoon, everyone. Welcome to the Wildfire Prevention and Resiliency Breakout session, the final session of the day. I'm Caroline Thomas-Jacobs, Director of the California's relatively new Office of Energy Infrastructure Safety, and I will be your moderator for today. In this session, we're going to learn about how EPIC-funded decision support tools and resilience-enhancing technologies are helping respond to climate impacts in the electricity sector. I'm joined today by 4 distinguished panelists who will each provide a few introductory remarks on the areas of research and development they are exploring in their various capacities, and I will then facilitate a discussion among the panelists and close it out with an opportunity for questions from the audience. A note to audience members who have questions: we will be accepting questions through the chat, so please be prepared to write your questions as we come to that portion of the discussion. So joining me today are David Saah, Managing Principal and Co-founder of Spatial Informatics Groups. He is also the Principal Investigator for PyroGENS project and a Professor of Geosciences at the University of San Francisco. He'll be discussing his EPIC-funded PyroGENS project and how it is being used to advance sciences related to wildfire models and extreme weather fuels forecasting and vegetation. Welcome, David. Also joining me is Bryan Jenkins, Distinguished Professor Emeritus in the Department of Biological and Agricultural Engineering at UC Davis. Bryan will be discussing the development of a decision support system for economic and environmental feasibility assessments of electricity generation from forest biomass to help address fuel reduction. Welcome, Bryan.
Thanks.
Next, we have Kevin Johnson, Principal of Wildfire Partnerships at PG&E. Kevin will be discussing the work his team does to develop public-private partnerships addressing community wildfire resilience, forest health restoration, and wood management. Welcome, Kevin. And finally, we have with us today Tony Johnson, a consulting engineer with Southern California Edison. Tony is an internal consulting engineer serving as chief engineer for Edison's EPIC-3 program, and will be discussing Edison's research into resonant grounding and how it addresses sensitivity and fault current. Welcome, Tony. So the purpose of this session is to discuss how new technologies are helping respond to climate impacts on the electricity sector. It's about innovation and how innovation can move the energy sector forward in an evolving climate. The department that I have the privilege to lead was established through legislation passed in the wake of the tragic fires of 2017 and 2018. Since 2020, we've been charged with overseeing utility wildfire mitigation plans. And at their most basic level, those plans explain how utilities understand their wildfire risk, what they're doing about that risk, and how they are improving over time to get ahead of our evolving climate risk in California. Given the enormity of the escalating wildfire risk since our department's founding, I've always believed that the only way for utilities to get ahead of this wildfire and climate risk is to innovate their way out of the problem. And we're seeing that now over the past several years. Utilities are innovating new organizational structures, innovating on risk models, innovating on weather forecasting, innovating on design and construction standards, innovating on grid operational protocols, and the list goes on. So each of our panelists today are discussing new innovations in the utility wildfire resilience space. So I'd like to ask the panelists, as you're discussing your topic, as much as you can, given your prepared remarks, if you can think about making a connection to the specific wildfire mitigation efforts you're aware of in the electrical sector. Speak to how you see innovation is changing the way electrical corporations generate, build, operate, and maintain California's grid. And I look forward to the discussion after your presentations. So with that, David, I know you're discussing risk modeling. Let's start with you. So over to David.
Thanks, Caroline. There we go. So as Caroline said, I'm a principal in Spatial Informatics group. I'm also a professor at the University of San Francisco and lead PI for Pyrogens. It's an open source program that's focused on building the next generation of wildfire models. And the way you do this is you have to break out this problem to a bunch of different sub-problems. We go to the next slide. And when you think about wildfire modeling in general, there's a bunch of different dimensions to it. One dimension is getting an understanding of extreme fire weather and wind. And we have that's being led by Janice Cohen. And in that task, you have a whole bunch of different sub-elements that we're focusing in on. One of them is nailing down a historical fire weather analysis, identifying where our weather stations currently are located and if there's blind sides to them, and identifying new technology that could be deployed and tested. And if you notice, there's some organizations that are associated with it. The next challenge that you have connected to weather is fuel mapping, fuel physics. That's being led by Scott Stevens, UC Berkeley. Mark Finney is also part of that group with the Forest Service and a variety of other collaborators. And the goal there is to get a better understanding of what fuels look like on the landscape, see how that could scale out, test those new fuel regimes at small scales, test them at large scales, and see how that new learning can get integrated into the next gen of models. Group after that is led by Chris Lautenberger. That's really focused on near real-term wildfire forecasting. What are fires going to be in the next 5 to 10 days? And how does that impact our grid? And there's a whole bunch of different systems around there that we could talk about. And then there's a long-term forecast, and that's being led by Leroy Westerling down at UC Merced. And that's to really try to figure out how to develop coupled models that integrate climate and veg models to look at potential long-term scenarios downwind, right? And if you go to the next slide, each of these different elements need to get connected somehow. We're trying to learn how to fill the gaps in base research and applied research for fire behavior mapping and fuel mapping. Same thing on the extreme weather tools. That information feeds into that next generation of wildfire models. And those are a suite of models. Those fit into a whole series of different tools that can be used for forecasting, both short-term and long-term. And the idea is that on the implement side, the short-term tools could be used by electrical utilities as well as a bunch of other organizations to lead to long-term safe and reliable cost-effective grids. And then the long-term models will lead to the same sort of thing. So you have a short-term approach, a long-term approach, an open science approach, and a connectivity between base research, applied research, and action. This is a system that gets put into place so you could do agile learning on the fly and make these things available and accessible to people. And this sounds like a pretty slide. How do you actually put it into action? So let's go to the next slide. There's a variety of different places where we've been able to see where this works. So on the for that first working group on the weather station optimization models, we've been able to identify better places to put weather stations. On the Pyrocast models, the near real-time models, we've been able to identify where wildfire risk is from the grid and to the grid short-term across the entire state. We've also been able to track active wildfire spread for every active fire that occurs in the United States. So we've been able to take this investment that California made and been able to push it out nationwide just because of the innovation and scaling that we've been able to do in that environment. And then on the long-term risk models, we've been able to put out specific scenarios for long-term projections that are also consistent with some of the new learnings that are occurring with the GCP models that are out there. We go to the next slide. What are the benefits of rate players, right? So we really believe in this open source, open accessibility approach. Everything that we're building is highly available in terms of the science itself, the models themselves, and having the general public, the ratepayers, being able to access that information in a way that's transparent, out there. The other thing that's been interesting is that the forecast for wildfires themselves allows us to be able to identify places where we could do treatments, position equipment, personnel, help plan for community evacuations, and also help inform how PSPSs could potentially be planned and implemented. The risk and hazard outputs, it's really interesting because those are being used quite a bit by these communities that are living on the edge. These communities that typically don't have this information. It costs a lot of money for them to develop that sort of understanding. Distributing this to those sorts of information, to those sorts of communities, gives them accessibility and an equal voice when actually having these larger conversations. It's meaningful to those red players. And then the last one, which we talked about earlier, was the more like, how do you actually build an infrastructure that's more resistant and resilient to a changing climate, including the placement of weather stations. Now, if you go to the next slide, who's actually using this? Can we go to the next slide, please? Like where is this currently being used? On the weather station optimization model, a variety of different utilities and non-California utilities are using these approaches. In terms of the Pyrocast model, which is that 10-day, 5-day, 10-day forecast, on average, we have during fire seasons, upwards of 8,000 users on any one page at any one time. Several IOUs are actually using it inside of within their own data sets as well. The fire behavior labs are also using it, along with a variety of other programs. And this is what's neat about the open sourceness of it, where it's integrated into things like Wildfire with the UC San Diego, or for those of you who have heard of Fire Factor, the product that comes out of the First Street Foundation, where you assess the fire risk for every property in the country. These models are feeding into that as well. And there's also a large program that's being deployed in the state of California right now called Planscape, where you're trying to identify where to put treatments across the state to build more resilient communities, including a more resilient grid. These open source models are being fed into that. The long-term models are being integrated into the CalAdapt analytics engine, and it's also being fed into the 5th climate assessment. So there's a lot of things that are happening here, and I'm looking forward to the questions and answers and the conversations that go forward. Caroline, back to you.
Oh, great. Thank you so much, David. Appreciate it. Next, Bryan Jenkins.
Yeah, thank you, Director Thomas Jacobs. It's a pleasure to be here today, and I greatly appreciate the invitation, and thanks to all the organizers for this. So this project involves the development of a decision support system to help understand some of the potentials around additional electricity generating capacity using biomass feedstocks coming from the state's forests. Before launching into some of the details of this system, let me acknowledge the people who really did the work on this. In particular, a special thanks to Tanir Karal, who's the Commission Project Manager, for all his support and assistance throughout this project. From UC Davis, Dr. Boon-Ling Yo served as the project manager and coordinated with all the students and other research staff in building the system to its current configuration. Dr. Carmen Tubasing from UC Berkeley was instrumental in developing some of the forest treatments that are used in the system. And Dr. Prasad Bondaru from the University of Maryland and his students assisted in translating some of the original spatial resource data into the more compact form that's actually used in the system. The project was also supported by the Technical Advisory Committee, comprised of experts whose input was immensely appreciated, highly valuable, and a number of administrative staff, and both from UC Davis and the Commission also supported the project, and I want to extend my thanks to all of these. The next slide, if you will, please. So the objective, as I said, was the development of a decision support system around forest resources for electricity generation. The system design follows typical decision support system development and interfacing users with an interactive computer model that allows for more systematic comparison of alternatives and the consideration of different viewpoints, objectives, impacts associated with, in this case, biopower project. The system embeds a substantial amount of data in several solvers or component models to derive potential economic and environmental outcomes associated with the project. It does not yet include any automated decision analysis or decision-making routines that are sometimes included in the decision support system, although future development might go ahead that way. Next slide, please. Yeah, so I won't go into all the details here, of course, but just to point out that the structure of the system incorporates several primary modules, including spatial resource identification, harvesting, transportation, and delivery feedstock to a user-selected facility location, the conversion technology and product delivery specifications, the techno-economic modeling yields a levelized cost of energy, for the system, and a partial life cycle analysis estimating direct greenhouse gas emissions and criteria air pollutant emissions for a project. In its present form, the model also uses resource data from the F3 group out of the U.S. Forest Service, and many thanks to them for providing this information. For those who may be familiar with the Fuel Reduction Cost Simulator, or FRCS, developed by U.S. Forest Service and UC Davis some years ago, a reprogrammed version of FRCS is included in the model, along with several other component models and routines, some of those which are independently available now online. Next slide, please. So the model is accessed online through this interface, allowing user input information or the use of default values in the model. For those using the default values, please check to make sure the values are appropriate to your particular project. In summary, the system is really designed to provide a preliminary assessment of feedstock availability, treatment alternatives, and biopower system development. Hopefully it can inform planning, policy, community engagement, strategies to support development for markets for forest feedstocks, complementing sustainable fuels management, economic development. A lot of connections also to what David was talking about. The model is now undergoing further integration into a larger state-supported digital marketplace for woody biomass. This leverages commission-supported development of this model through UC Davis, as well as the California Biomass Residue Emissions Characterization Model out of Cal Poly Humboldt, and with Office of Planning and Research supported online marketplace design, which is being really coordinated through Cal Poly San Luis Obispo. The initial support, some of the pilot projects through the Biomat program is also there. And we've had some discussions around that, really in terms of, again, sustainable forest management, including fuels from the high hazard zones. So I'll leave it there for the time being. A lot of the ratepayer effects and the like are similar in these model application to what David was talking about. So we can perhaps discuss some more of that later. Thanks.
Thank you, Bryan. Again, really look forward to being able to talk about this a little bit more in the discussion portion. But with that, we'll move on to Kevin Johnson.
Great, thank you very much, and thank you for having me. Appreciate it. So I'm going to talk about wood management innovation today, as a component of wildfire resilience. And go to the next slide. You can click on through. Thank you. So why work on wood management innovation as a utility? Have come at this from a few different angles. So first, you could look at risk, and wildfire risk is something that PG&E obviously cares quite a bit about. Is really likelihood of risk times consequence of an event happening. Right now, you could characterize California investor-owned utilities spending about $10 billion a year trying to prevent ignition from power lines, which historically have caused 6 of the 20 biggest fires in California history. And the utility customers basically bear the burden of that upgrade through solutions such as undergrounding or overhead hardening or microgrids or other solutions. The right side of the equation, wildfire resilience, there's about $1 billion spent as opposed to the $10 billion per year from California U.S. Forest Service, is something that could prevent all catastrophic fires and not just ones from power lines. And it can be split across many stakeholders, given that there's shared value in creating that resilience. And so basically a bigger picture trying to establish, can utilities help influence wildfire resilience and potentially rebalance that portfolio rather than just focusing on ignition prevention? And on the right, you can see kind of a way to look at wildfire resilience overall. As I see it, there are 3 different interlocking components to really creating that kind of resilience. One is making communities more resilient to wildfire. Second one is landscape scale forest health restoration. The third one is wood management and conversion, which is what I'm going to talk about today. And how I really think about that is that if you make that very efficient and clean, wood management, that really strengthens the ability to make communities resilient and really strengthens the ability to do forest health restoration by driving down the costs and make it more viable to be able to process a lot more of this output. And so basically every dollar spent is or saved can then help translate to more wildfire risk achieved moving forward. So I see this as kind of an enabling function that can provide a lot of good. Also, PG&E could spend up to $100 million in a given year on operational wood management. So even a few percentage points of savings can add up to pretty big numbers pretty quick. So those are some of the reasons as to why we chose this project. Next slide. So to introduce the project overall, basically we did a request for proposal and got 5 innovative vendors who came back and who we selected for the project, and some emergent kind of themes. One is to bring the machine to the wood rather than the wood to the machine. Wood is very bulky, it's heavy, it's moist, it's expensive to move. It means a lot more trucks. And it seems like there's a big opportunity to try and process the wood closer to the site, which then creates all sorts of value. The other side is that wood waste wood is still an inherently potentially valuable product. And it seems like there's opportunity to unlock that value and to turn this waste wood into climate positive products. So this is really a kind of uniquely cross-functional team, utility partnerships team that I'm on, an innovation group, working with our vegetation management team, working with our gas and GHG strategies team. And so you can see it's kind of a broad cast. And then kind of what are we trying to accomplish? Really, I mean, maybe we should put the bottom one here on top, people and safety. If we can drive worker safety improvement and drive public safety improvement, that's a big outcome. Number 2 is if we can achieve more risk reduction and more operational outcomes at less cost, that's great. But also if we can create new jobs and industries in the process with all this waste wood, that's another plus. Then last, there are a whole lot of different ways that we can create value for the planet, from reducing trucking to reducing carbon emissions to reducing criteria pollution that can affect surrounding communities, reducing waste. And wood is actually an opportunity to remove carbon from the carbon cycle, to be carbon negative, or to displace fossil fuels and other hard to decarbonize industries. So those are all potentially in play with these projects. Next slide. So go ahead and click through. So these are 4 of the technologies that we piloted. One more click, please. Great. These are 4 of the vendors and technology we piloted. These are all I would characterize as prototype stage. They are all show promise, but really it's 2024 or beyond when we're really going to see these kind of come to market and be able to take advantage of what they bring to bear. The first one on the top left is named Takachar. It's a mobile pyrolysis technology. We demonstrated their small scale prototype in Q3. And really, it showed a lot of promise. It had a high conversion efficiency, turning wood into biochar, which is this kind of climate environment positive product. A very simple design that is portable and could theoretically be permitted year round. It's really exciting. But they're now building a larger scale prototype, which will soon be demonstrating, after which they then come out with a commercial product. The second one, Biogas Energy. This is more of a stationary biofuels company. And it started out as a bio oil company. They're transitioning to becoming a syngas company that can make RNG and hydrogen. They received a Department of Conservation Engineering grant to really develop this technology as a potential future biofuels solution. And in the future, they could absorb a lot of operational PG wood, in addition to wood from other sources as well, and potentially could have a positive impact on the pipeline system in the process too, in addition to the climate. Third vendor to highlight, Charm Industrial. They are another mobile pyrolysis solution, but they create bio oil, which can then be sequestered underground for carbon removal payments. And they've already gotten big contracts with some big tech companies for initial carbon removal services. And basically they could put this oil underground and effectively take advantage of stranded California oil wells and put them to good use in terms of making those storage facilities and then tightening them up so they're not a potential future source of leakage. So really interesting shot on goal. And again, they're making a unit that could take their machinery and potentially take it closer to the wood sources. And then last, BurnBot. They make kind of a movable controlled burn chamber where this machine that you can see goes over the ground and there's the black trail that comes out the other side behind it. The idea is to be able to do safe controlled burns in places where it might otherwise be difficult to conduct that. You can see in this case, we demonstrated actually underneath transmission power lines and also around houses. And this is a kind of technology where you could safely do these kind of controlled burns in that context. This is also a prototype that'll be coming out, a commercial version coming out next year. We've done 1 demonstration so far and 2 more to come. We've already identified this could be a unique solution for control lines versus herbicide for managing invasive species and or herbicide resistant weeds. Last slide, please. So 2 technologies I want to highlight that are commercial ready and we're really taking the step of trying to learn how to integrate them now, which is a really exciting place to be. So the first one, the remote masticator, also from BurnBot, it looks like it can be a helpful solution for mowing, for thick brush clearing, and for thin diameter tree thinning. And it can manage, it can work on steep slopes. It can work in dangerous conditions such as roadside without putting workers in harm's way. It can manage tricky fuels like poison oak and brambles. It's kind of a precision tool as well. It can be smaller, and there's a great deal of situational awareness for the operators who are managing from the side. You can have theoretically a fleet of these in any one location to kind of chew through a lot of ground in a little bit of time. And so versus hand crews, this is a very, very attractive solution. We're working towards getting a contract with them now to be able to integrate this more operationally into PG&E and start to get some of the savings, both from a monetary perspective, also environmental outcomes and worker safety. The other one worth to highlight is the Carbonator, which was provided to us as a service by a company named Earth Foundries. And this is it's like an air curtain burner, but it actually creates biochar. And we found it to be really advantageous in a number of different ways. Some of the key use cases are to manage surge wood, for example, from big piles of wood after a wildfire cleanup. Also, it can be helpful for blue sky wood piles too, but probably in partnership with other organizations. And so some clear advantages to this technology is it densifies wood close to the site. So if you put in a pound of wood, you might have 0.08 pounds of biochar coming out the other side. Those 0.92 pounds are all savings from avoided trucking, avoided fuel, avoided criteria pollutants, and the disturbance that trucking represents to all the customers who might be nearby. Has this high throughput efficiency, so it can handle a lot of wood in a small amount of time, and it creates biochar as well, which is an environmentally friendly product that in turn could also, in theory, in the future, attract carbon removal payments or payments for the actual biochar itself, which could be a soil additive to improve agriculture or all sorts of other uses. And so the interesting thing is we don't have as many big wood piles this year as we have had in other years. So in order to take advantage of the economies of scale that this represents, we really need to look at wood management potentially differently, where we could work with other groups with wood, and those could be timber operators, those could be CAL FIRE, it could be resource conservation districts or National Forest Service, for example. And we basically, if we can pool wood together above a certain threshold, we can start to get per unit savings that everyone can benefit from while turning this wood into a very valuable thing. And these are mobile units, so we can take them all around the state, and when we have enough wood piles, we can have that helpful conversion. I can see a long-term future where we might have more big infrastructure like biogas energy represented, but this is potentially a stepping stone. And you could also, with this model, also potentially put in Takachar or Charm or other such technologies too, but as a potential kind of an intermediary model to be able to absorb a lot of the wood that's hopefully coming as California continues to de-risk itself. So I will stop there and turn it back over. Thank you.
Great, thank you, Kevin. So we'll go on to our fourth panelist, Tony Johnson.
Come off mute. As the EPIC chief engineer, I get to understand and have knowledge of all of our EPIC 3 projects. As it mentioned here, Jesse was the project engineer for this, and he and the construction guys that did the installations made this successful. Next slide, please. Now there's 3 characteristics you need. You need the sensitivity, the time that remains on the system, and you want to reduce the overall energy. Resident grounding starts addressing some of those. This has been proven out in Australia and Sweden to identify, so we're adapting their technology that they've already proven out in some other areas. Next slide, please. So resident grounding basically places a coil in the neutral of the transformer. But the one thing it does that's really important, if I were in the room, if we were all in a room together, I'd ask you, how many of you actually seen a solidly grounded fault? So go ahead and play this movie. As you can see, there's a little bit of energy when a wire hits the ground. And it causes all types of, it can cause fires and everything else. If you can remove that energy, next slide. If you look here, this is our EDEF facility where we have actually our energizing equipment at distribution line voltage, so 12 kV. The setup here is we're going to introduce a fault to the conductor, and underneath that conductor is some dry straw. Go ahead and play the movie for this one, please. Now, that spark is enough to say that this was energized, but it did not give enough energy to the straw underneath to actually start a fire. Even with, the other conditions that we have that we can stop things, this is looking at it from a thermal cam perspective. You can see there's that little spark showing that there's a little bit of heat, but it's not enough to, and it doesn't sustain long enough to actually start a fire. So this system, next slide, please. We did a large number of tests on it. We looked at, the different scenarios here, and it substantially reduced the chance of ignition of a downed wire. And that's really what this project was going to be. The goal of this project is really to do that. Is you can do everything in trying to insulate and remove the wood or remove the fuel, but also if you remove the ignition source, that also helps reduce the chance of a fire. Next slide. I think it's the last one. Oh, yeah. Okay. This is basically where we installed it in the field. That what I was showing before was not the field install. This is the field install. The reason we did the testing in EDEF is otherwise be waiting to see if it worked at a facility that would be waiting for a fault. And we really don't like doing that, but this is, you're installing it in the field, in the neutral of the transformer with some electronics to control it and signify which line has the fault on it and isolating that line. I think this is the last slide, but let's try one more just to, yep. Okay, that's it.
Great. Well, thank you, Tony. So now we'll move over to the discussion portion, and I'll kind of tee us up with some initial questions. And then again, audience, feel free to put them into the question and answer section. I see that there've already been a couple questions put in there, so I'll get to those when we get to the audience portion. But David, we can kind of go back to you with the risk modeling, because that's kind of where, to me, it really starts, right? Is how do we understand what the risk is? Could you speak a little bit to some of the challenges that you guys have in both the development of the open source risk modeling and then in terms of the future adoption of the risk modeling?
Yeah, there's a variety of them. And with those challenges, there's also a variety of opportunities. On the long-term risk analysis side, we're completely dependent on some of these newer long-term climate data streams. We're dependent on them. And if they're not produced in time, then these sorts of products become a challenge. And so then the question becomes, how do you abstract the analytics so they could not only get built while we're waiting for some of these new data streams to come in, but how can you build them in a way when the next generation of data streams fit in? So there's an architecting challenge and solution set there that we're working on quite a bit on the long-term risk scenario side. On the short-term risk scenario side, the idea here is trying to accelerate the science into information products, Caroline, that you and your organization could actually use. And there's some real gaps in some of this base research that we need to fill. A lot of these plume-driven events aren't really well understood. How do you make space in these models that you're generating to be able to ingest that science when it comes down the pipe to be seamless with the rest of the systems that people are thinking about? So as part of this innovation, part of this open science framework or platform that we're building is taking a lot of those basic challenges and pulling them in. Some of them we're hitting head on. We know there's gaps, for example, in getting a better understanding of plume-driven events. And the science is missing on that. So we're working with the Rocky Mountain Research Station and Missoula Fire Labs to build grain silo sized fuel fire chambers where we can get that understanding. And then when you look at the models that fit both into the long-term forecast and short-term forecast, there's a placeholder there ready to take in that science as it pops in. I hope that's, without getting into a whole bunch of technical details, that's the generalized approach that we're thinking through. The other challenge that we also have, Caroline, is like, what does the end user actually want and how do you get adoption to it? And there's so much money, I think, as Kevin was saying, $10 billion for vegetation management just for the utilities in California. There's so much money, there's so many resources, there's so many different sectors pushing in solutions. It creates a lot of noise in the system. And trying to separate out what is just an opportunity effort versus what is a meaningful, long-term, durable, scientific pathway effort sometimes is very hard, especially when you're working with some of these smaller communities that don't have access to a lot of these information streams. So that's why the accessibility thing becomes really important to this whole effort.
Thank you. I just to follow on the sort of the evolution of the funding, I couldn't agree with you more that it's really interesting, especially with what our department does in terms of reviewing the wildfire mitigation plans and how the plans are evolving, right? It's all about maturity and kind of keep pushing forward. You know, now that we're about 4 years in of these plans, you know, now is the time when we're starting to see like, okay, well, maybe the initial investment needed to be over here, but as we've evolved and innovation has evolved, now those investments need to shift, right? So there is an evolution that has to be considered. I did want to give you a chance, actually, just that first question that you answered in the chat, if you don't mind, because you talked about plumes and that has a little bit of a relationship to that question in terms of the impacts that are, I'll call downstream or downwind from the wildfires. Could you maybe speak a little bit to how that plays into risk modeling?
Yeah, so when you like, especially with wildfires, I mean, we're the receiver of that risk, and sometimes we're the ones that actually were producing that risk. And these are large landscape, regional scale systems that we're trying to figure out how to model out. Like in the example in the question was like, you know, if you look at the Canadian fires that are occurring in there, our school got shut down twice, and I'm in San Francisco. We had two days where we got shut down because of that air quality. And so then the question becomes like, well, how do you integrate that into the stuff that we're trying to do in the state of California? Right? That's a great question. And so one of the approaches is like, well, if we're able to create these open platforms where we're able to integrate information streams that allow us to pull information in from other regions or other disciplines or other sciences, then all of a sudden now we get a more holistic view of what's actually happening there. And then if you look at the link that I stuck in there, it's actually a link to one of these NOAA products that's actually looking at smoke emissions that's being captured Konos wide, where we could actually see that smoke coming in from Canada. And then to the two questions that the participant asked, like, well, how do you link that to air quality and solar quality? That would be a handoff to another organization that can actually potentially identify thresholding. Flip side, if you want to actually look at how do you mitigate risk inside the state of California, sometimes we have these bordering issues that we need to manage in a very effective way, right? And so one of the examples that we have is that, you know, the malls that we built inside the state, we've been able to push out Konos wide, where we're able to track every active wildfire that's occurring in the state or in the country. With that actually got picked up by the Department of Energy, where the Secretary of Energy gets a briefing twice a week to see how those fires are going to interact with the national grid. And those interactions impact us directly in the state. So a fire, for example, that occurs in Texas might have a direct impact of what's occurring here in California. So that investment that we made here and our ability to be able to scale and keep things open allow us to cross that boundaries in a variety of different ways. And then the last example I'm going to give is the one that Bryan was talking about with biomass utilization. That is a huge challenge. So let's say we are able to get down and get this vegetation management down to a point where it's actually meaningful. The infrastructure necessary to actually consume that material, right, and to deal with it in a meaningful way so we could actually reduce that risk, we might inadvertently create another massive challenge for us that we have to deal with. So it's those interconnections is the way that we're able to deal.
Well, thank you. That actually leads really well into my next question, because I kind of wanted to shift over to what Bryan and Kevin both discussed from different perspectives. So the utilization of the wood, right? So obviously, currently, and at least for the near term and medium term, vegetation management is at least one way of mitigating risk, right? Climate risk, especially on the infrastructure. So I was wondering, and this is kind of both to you, to both Kevin and Bryan, you guys can speak to it from your different angles, but could you maybe speak a little bit about what I'm interested in is it's the transportation. So Kevin, you talked a lot about that, the bringing the devices to the wood as opposed to the wood to the processing. And I know, Bryan, you talked about like the siting of the different biomass facilities and fuels treatment facilities. How does electrification of the transportation sector, so e-trucks, potentially make that blend have more opportunity, right? So maybe some stuff still should be brought to the wood, but now maybe it's less climate impactful and less expensive to bring the wood to centralized sites. I'm curious if you have thoughts on how the electrification of the transportation sector might change that dynamic.
Well, I don't know that a lot of thought has gone into that so far in terms of how this model I described approaches it, although the analysis can be done there. As we have, if you refer to electric trucks and whatnot out in the field, then of course there's the whole issue of can you have enough energy stored on board the trucks to navigate through these difficult terrains in many cases, and do you need electric infrastructure out in the field in order to support that? So there is that. The FREDS model, this decision support system we developed, allows any scale to be considered. And for the state, there is a huge scale of resource here that needs to be addressed, and we have to get to some level of scale. We can do a lot of that in the field. I think with Kevin, the types of technologies that Kevin addressed, I think there's a lot of potential there, but there's also this basic issue of how do we get enough material into the scale of treatment that we can find the markets that will adequately address that, rather than relying on more open burning and that type of thing that will probably increase local emissions more than maybe is possible in a centralized facility. Although there are obviously, and have been for a long time, concerns about centralized facilities burning biomass and converting in various ways, and those effects on local communities as well as the state overall. So, Kevin, I don't know if you had anything to add to that.
Yeah, it's an interesting question. And this is a bit secondhand, so I want to caveat that up front, but other people who seem smarter than me have told me that electric trucks are tough to get up into the mountains to do a lot of the heavy lifting. They don't have the torque, and the battery capacity the same way. And so interestingly, I think wherever we can get electric trucking, and it's cost effective, great. There are also the options of hydrogen or compressed, renewable natural gas too. And my understanding is those might be a little bit better positioned for a lot of the rugged terrain that a lot of this wood would come from. So, and then when we get to a freeway, then the electric truck may be able to pick it up from there. So I feel like there's some sort of a combination to come in. But the other interesting thing is that, all three of those products could theoretically come from electricity while sequestering carbon. So I think it all could tie into an interesting future, but it may be location and context specific.
Oh, thank you. Well, Kevin, just kind of sticking with you, could you maybe speak a little bit about, talking about the scale, right? So the need here is orders of magnitude, right? Larger, it's huge. So how might some, other EPIC solutions help in terms of addressing that need?
And let me, I guess, clarify the question. The need or the opportunity, which one are specifically you're referring to?
So the opportunities, the follow-on opportunities.
From this work.
Yeah.
Yeah. So, one thing is that we're trying to test out new technologies and business models. Some of the ones that we're looking at near term, partly because you don't have to do CEQA, permitting, you don't have to try and, build something big in California. These modular solutions can kind of, it's more the speed of a factory rather than the speed of permitting construction in California. So theoretically, we could get a lot of these modular smaller modular mobile solutions out there, I think in a matter of a year or two rather than 5 or 10. And so I think that's part of the future, is just proving out the technologies and also the models, and then figure out, in some respects, how do we work together so we can all take advantage of these solutions as more acreage, inevitably needs to get treated. I think there are other solutions. So one of the things I'm looking at for maybe future EPIC projects is how do you look at an overall value chain, and integrate clean trucking and potentially lower emissions, treatment, and this kind of carbon removal component, and maybe the idea of wood depots that are a little more flexible to different sources. I think if we look at this as an integrated component, again, with modular features, it'd be interesting to know what is the optimal kind of setup in a state that is going to be treating a lot more acres than today. So I think that's one. I think being able to characterize, how much wood is out there, and I think some of the kind of modeling that David's work is doing and others, knowing kind of where is the wood, how do you value that, and interestingly, the processing of the wood could actually pay for a lot of the resilience work. So if the waste wood becomes high value, all of a sudden these projects that are really expensive today maybe break even in the future, and then when you factor in the risk benefit, it could be really strong. So I think just building layer by layer, and there are new systems that need to be put in place. There's not one solution, and there are interdependencies and supply and demand. You got to build it all at the same time. But I think if we take deliberate approaches to kind of build this infrastructure, I think it could be a pretty interesting solution where this waste wood turns into this very clean resource for the future while we lower wildfire risk at the same time.
Thank you. Well, Tony, I want to move over to you before we run out of time here. So in your the resident grounding, can you speak a little bit to how Edison is planning on deploying this technology to address wildfire risk?
Sure. I mean, it is a technology that we've now included even before the EPIC project is fully complete. It's not scheduled to be complete until sometime next year, but actually we've put it into our wildfire mitigation plan. And we've also included it into our rate case, and to get it out to, I believe that the potential is out to about 100 substations where we can put it out and get it installed there. Of course, I'm going to kind of address the question as well. The challenge, of course, is not all our distribution circuits are a match for the technology. And then, of course, because of the way it operates, it isolates the entire circuit when it detects a fault on the circuit. A lot of the fault location algorithms and fusing will not work. It happens too fast, and it happens at such low current that those typical ways of doing things no longer applies. We'll have to figure out how to address that with a longer patrol time or something like that as we get into this realm.
So can you speak a little bit more? I don't think I quite picked this up in your presentation of. You said it only works on certain designs of system, correct? Right.
Yes.
Could you kind of clarify that a little bit of and then what?
This is going from my memory, so yeah. I may be wrong. I don't think I am, but we have different types of distribution substations. Edison's made up of a large number of utilities that we have come merged together over time. One of the ones that is the most common that we have is solidly grounded, which basically means the transformer is solidly tied to ground at the substation. Those, I believe, are the types of installations that this works for best. The other ones where you don't have that ground on the distribution side of the transformer, it's delta Y versus Y delta. When you look at the way they connect, you'd understand it. But basically, it's whether you're connecting line-to-line voltages or you're connecting line to neutral. If you're line to neutral on the distribution side, this technology has a greater chance to work than if you're not. If you're line to line, we haven't seen how to apply this technology in that mode yet. But fortunately for us, it applies in most of our substations that we've got in this area.
Great, thank you. And then I see we had a couple questions here. I want to give some time for the comments from the audience, which I see we have a couple. One's already been answered, I think, at this point. Tony, I believe you've answered the complexity challenges question, yep. Correct? Okay, just want to make sure that one. So the one that we have open is, I'll just read it out loud just real quick. Biomass is getting pushback from communities who are concerned about air quality consequences despite controlled burning PM being much lower than wildfires. What literature is available to help educate the public on the trade-offs so they can support sound biomass? And I'll kind of maybe expand that question a little bit. more than just the pushback on controlled burning, right? The air quality impact, but also just the, let's call it infrastructure, construction, noise, large vehicles, heavy equipment can push back sometimes in terms of their communities. Could you maybe speak a little bit, Kevin, to what opportunities are there to help educate the public or just address those concerns?
Yeah, and I feel like biomass is such a big topic. I think often people think about biomass electric generation, which is frankly, surprisingly, something I could probably speak less to. But the commenter is right that there are trade-offs. If you have these mega fires, the amount of pollution just dwarfs anything you'd have from controlled fire. And controlled fire can restore landscape health with a bit of air pollution. It's a very, very real trade-off. What to best do with this waste biomass, I think it's still an open question, which is something we've been talking about on this panel. But yeah, I don't have there's no silver bullet to this question as far as I understand, and I'm interested to know what some successful pathways are.
Thank you. So another sort of, this kind of loops back to my tee-up question. Could each of you maybe give just a really specific example of how your specific area of research or tool or technology is being used today for wildfire mitigation, either in a pilot or being deployed if it's not quite there yet? But kind of apply it to the real world of how is this being used? And Tony, I'm going to start with you only because you're up in the top corner of I'm going to go clockwise here.
Yeah, like I showed in my last slide, we've actually installed it in a live substation in the field. And we're planning on doing, I think, 2 more next year and then expanding more as we get approval in the rate case beyond that. So this is really to reduce the risk of wildfire in those areas by removing the ignition. If you can have all the air and fuel, but if you don't have a spark to start it, then you're removing that ignition source. And that's one thing that we're trying to do with this project.
Great, thank you. And then Kevin, you're next in my circle here.
Yeah, so the partnership, wood management partnership, we're trying to build a couple of those right now. And basically it's just others who have wood and we have wood, and we cost a certain amount to dispose of that wood now, or it's left on site sometimes in the case of others. If we can generate better economics for ourselves, then everybody wins. And again, we could prove out a model. So right now, the short list looking in kind of the Tahoe Central Sierra area and Lake County are the 2 that just kind of have naturally come to the top. If you have wood in those areas, reach out to me. Maybe we can work together. But really gonna be opportunistic where there's the right regulatory regime, the right kind of counterparties to kind of create this first model, prove it out, and then be able to scale it.
Great, thank you. David, how about you?
Yeah, no, the tools and technologies that we're building are actively being used in the planning process from local, state to national scales. The other thing that's interesting, and I can give you a variety of different examples there, Caroline. I think the tech adoption slide has a list of them there. The other interesting thing that we weren't taking into consideration when we first built this out was how the private sector was going to be able to grab and leverage it. And so we've seen, since they're open tools, a variety of different technology organizations, insurance organizations, and foundations that are picking up the tools and building it into their platforms. So for example, if you go to realtor.com and you were to look up your property and you were to look up a wildfire risk score, that's there. That's coming directly from the models being built in PyroGens. And you see the same sort of thing in the White House environmental screening tools. I can just give you a list of examples there, but it's amazing how fast and far these sorts of tools and technologies can reach out if we keep them open.
Thank you. Yeah, no, it is fascinating, having been someone obviously involved in this work for multiple years now, how it's just becoming part of the common person's discussion and language, right? Everyone's understanding what climate change is, the impact of wildfire, what we need to model, air quality index, right? Like there's a common language that is now filtering across the nation, really. So Bryan, how about you?
Yeah, so I included a couple of items on the last slide there in mind about how this is being applied. I think the biggest approach right now is probably through this digital marketplace that OPR is supporting. And of course, there are a number of agencies involved with that as well, including CAL FIRE. But building out that model that incorporates much of what's already included in FREDS, along with these other the emission characterization and making providing opportunities for landowners and others to actually put their resource in there. It's one of the big questions, and I think Kevin alluded to this as well as David, is that getting good resource information for the state, and Caroline, you're probably dealing with this problem as well, and making sure that stays updated, is at a high spatial resolution, allows us to address many of the concerns over the various communities have, not only over air pollution, but other social effects and economic effects. Making sure that we can keep a statewide resource database available and updated, and actually be able to project things out into the future so that we can make good economic decisions that require 20, 30-year planning efforts in order to decide whether we want to proceed with the facility and like. That's going to be a key issue for the state, I think, moving forward, to try to get the capacity to do that in addition to the federal sources and other sources that may be out there. We've done a little bit of work. Some of the biomat projects, as I mentioned, are interested. We've had other commercial interests come to us and want to use the model. So we're looking to expand that quite a bit, and there's also quite a bit of opportunity to take this model further in risk assessment and really understanding some of the real critical parts of the decisions that need to be made, both in terms of the economics and environmental performance, but in some of the socioeconomic effects as well. So there's an opportunity there to take this model much further. I don't know if I answered your question.
Yeah, no, I think you did. Thank you. And I want to get, and I know, Kevin, you just answered a question in the thing, but I didn't know if maybe you could just kind of quickly just give a verbal answer for those that didn't get a chance to read that in terms of responding to that question.
Yeah, sure. The question was, what might win kind of the biomass conversion market in the future? And I don't know is my answer. Long term, because there are actually a lot of interesting, compelling kind of potential products, but they all have their drawbacks, and virtues and different dynamics that need to unfold. I think biochar could be a bridge. I'm pretty bullish on that because it's modular, lowers transportation, it's good economics, and there are more technologies coming out of this now. And also PG&E is mandated to procure renewable natural gas, which could come from wood, and so I think that's going to impact the price that output's going to have in a way that you don't see today. And so that might be an earlier candidate to absorb wood in mass, but again, lots to be figured out there.
Great, thank you. And then this last question, I'll kind of recharacterize it just a little bit, but the question revolves around the responsibility of the federal government in terms of wildfires, because obviously they are owners of a large portion of the state of California in terms of just land mass. So could maybe not necessarily all of you, but whoever wants to speak to a little bit of the collaboration or coordination you're doing with the federal government on the areas that your research centers around.
I could take that one on. So as part of what the state's working on, there's this task force, a forest resilience task force, where they're trying to build out information platforms that integrate both state, federal, and private information streams together. And you'd be shocked on how hard that actually is. So one of the things that we're trying to get lined out right now is this interagency tracking system to identify where all these treatments currently exist in a unified fashion across state, federal, and private lands. Next set of questions that pops up is, well, how do you actually plan on those lands? Because you got to deal with these fire sheds in an integrated fashion. The federal agency, especially the Forest Service, is working with the state of California to build out, again, open source tools to help address this. One of the tools is called Planscape. Planscape's fire modules are coming out of the PyroGence models. And so if you look at how all that planning is occurring, it's occurring in a way where you're layering in sets of knowledge and sets of information products that are trying to hit multiple management objectives. The Forest Service has its own set of objectives. Park Service has a different set of objectives. State Forest has a third set of objectives. How do you manage all of that within a fire shed in a way that's unique, in a way that's consistent with the infrastructure we have? So that planning effort and planning tools that are being built out there need to fall into some of these infrastructure conversations. And this is where you go right back to what Bryan is looking at and studying. It's like, well, how do you build a biomass infrastructure for the state that's able to capture what's needed on the planning side of the shop to be implemented at scale. And then once you get that done, how do you drill that down into the communities? Because the decisions are going to be made at the communities. Each community has its own separate set of sensitivities. One of the questions in here was some of the pushback from communities with local wildfire emissions. They're going to have their own separate set of priorities. And so the question is, how do you actually do those resource allocations and get those optics in a way where when you start marshaling this stuff up, you could actually try to accelerate these treatments in a meaningful fashion. So that's one large effort where this investment is directly impacting all of that.
Thank you, David. Well, I know we're coming up on time here, so just wanted to thank all of the panelists. I think it's, as I started off with the panel, really this wildfire / climate risk problem is an extremely complex, gnarly problem that is going to require lots of innovation. And I appreciate the different perspectives you guys are offering in terms of where you're investing and thinking differently about how we could tackle this problem. So thank you again for joining us. I also, being the last session today, want to thank all those in the audience for joining us today. This concludes the 2023 EPIC Symposium. The California Energy Commission will be making all of the session recordings available soon. And we hope you enjoyed the event today as much as we have. Take care.
Thank you.